Okay, here we are in Replicator G version 40. This is the version that was provided with my printer. I have a Wanhao Duplicator 4X, which I believe is a copy of the Replicator, hence the name. So when you open Replicator G, it will default into whatever you last edited. Now, I'm not going to slice the object I just made in Replicator G because one of the problems of Replicator is it's quite slow. I think it's a Java or Python based language, and it also struggles with very, very large files, and I suspect the STL file I just created is fairly sizable. But just to show you very briefly, if you've not used this before, this obviously represents the build plate. This is a large file, so it's struggling a little bit, but you can see the object I created, in this case a little vase, sits in there. We've got some basic settings down here. We can rotate it, mirror it, move it, and if we select move, we can then say center it on the platform. So if I move it over here and perhaps move it up as well and then say put on platform, it will obviously drop it to the platform and center it to the platform there. I don't have this computer connected directly to my printer, so I will be outputting things into a file. Obviously you can move things around. The step that you move them around is set here, and then you click plus or minus. We can also scale them in here. You can tell it to fill the build space, so it'll just make it as big as it can, and so on. And then when you're ready, you click Generate G-Code. It'll ask if you want to save them, and as you see, it's relatively slow. And then you carry on. And now, for my printer, I use the Replicator slicing defaults. I tell it which extruder to use because I've got a dual extruder system. Raft. So a raft, we'll learn more about that in a little bit, but essentially this is a flat bed of plastic that is extruded onto the build plate in usually a sort of zigzag pattern that then has sort of interface material, very thin layer added on top of it, and gives you a nice flat surface to put your object onto. Depending on what material you're using and how well it sticks to the build plate will determine whether you need a raft. You'll learn yourself which of your objects needs a raft. If you're going to use support material, I generally do put a raft down. So then we get into support material. You can say just around the outside or full support. So essentially, if your object had voids within it, obviously because of the way the printers work, they struggle to create areas out into open space. So you do something called support material, which can either be the same material or another material if you've got two extruders. And essentially it just builds little towers that allow it to print over empty spaces. And you can say just around the outside, the exterior support, or inside as well. You can set up some default start and end G-code. G-code is essentially a set of commands, and I'll show you what they look like in a moment, that tell the printer head where to go to and what to do when it gets there. Typically, if you're using Rep-G, use Printer-Matic stepper extruders on. I haven't fully got to grips with everything that does, but I believe you need it on. When you're printing a large object, you don't necessarily want it to be 100% infill. Normally the default is about 10. What it does essentially is when it's in that area where the water would be, in that watertight object, so between walls, it creates a framework of support for the outer and inner walls, rather than completely filling it with plastic, which obviously uses a lot more plastic. So typically, unless you need extreme strength, you don't want that at 100%. You're going to want somewhere in between. And Rep-G is very handy in reminding you what that means. So typically I would put that somewhere between 10 and 50%. One of the good things about Rep-G is it allows you a lot of control, and here we've got the layer height. Now my printer will print down to 0.1mm. Obviously that means the smaller that resolution, the longer it's going to take to print, but in theory the finer the detail that it can resolve. Shells is essentially, if you imagine this thing is drawing flat shapes one on top of the other, it's whether or not it goes round and draws a line and then fills the line in. The line is the shell, and how many of those shells you want. So if you need to make sure that the surface is well supported, you need a number of shells. However, if it's very fine details such as this thing, it can often struggle to fit the thickness of the shell as well as any infill, and therefore you can sometimes get problems. So generally with very fine detailed objects, possibly have no shells or very few. Typically you don't go more than 2. Feed rate, so this is how fast the head moves while it is feeding filament through. So you don't control, with Rep-G anyway, you don't control exactly how fast the filament's coming through. That's worked out based on the speed that the head moves at. And typically for finer details and finer work you go more slowly. These settings are very slow indeed. And then what temperature do you want to print at? I've been experimenting. There are quite a few differences between one type of material and another. Today we're going to be printing in PLA. Another common material is ABS. ABS has the advantage of being less brittle, somewhat stronger and more resistant to temperature, and I believe it's watertight as well. If you wanted to make a cup out of it, it would hold the water and wouldn't absorb the water. You can also smooth it using acetone. PLA, there are some chemicals which will smooth it, which I'm looking into, but acetone doesn't work. It's not watertight as far as I know. I believe it will absorb water, but I haven't tested that yet. And it melts at a lower temperature, so if you left a piece of material created from PLA in a hot car, it wouldn't necessarily completely melt, but it would sag basically. But that said, it's an easier material to print in. So typically you print between 190 and about 215 degrees C. Exactly what temperature depends on how fast you want to go, because obviously the higher the temperature, the less viscous the material is, and therefore you can squirt it out of the printhead more quickly. But there are drawbacks as well. So you tell RepG the size of the filament, which will be set by your printer. You'll probably have the option to use either 1.75 or 3mm material, but you can't change from one to the other. It's whatever your printhead is designed to accept. And then the nozzle diameter, because obviously this is calculating how much material is coming out, and in my case it's 0.4mm. And then you say generate G-code, which I won't do because this takes quite a long time with this tool, and it creates this, which is G-code. Now you can get crib sheets that tell you what all these codes mean. The writing in the red here is just reminders of what it means, aid memoirs, but the ones that I often play with are down here. So you can see, for example, here HBP means heated build plate, particularly if you're printing in ABS, but not just in ABS necessarily. In order to help it stick to the print bed and to minimize shrinkage, you typically heat the build plate. So ABS shrinks quite a bit as it cools, and if it's not stuck to the build plate very well, it will actually peel itself off if it's any sort of sizable object. PLA can do it as well, so you need to really look at the design of your object, how much material is there, how large it is, and whether you think shrinkage may be an issue. If it is, then you can heat the build plate, if you have one, to reduce that somewhat, because obviously it doesn't cool completely down. So by default this is setting the heated build plate to 100 degrees. I have printed PLA quite a bit onto Captain Tape, and I'll come onto all that sort of thing in a minute, at about 50 to 80 degrees. But typically now I don't have the heated build plate switched on while I'm printing PLA. So you can actually directly modify the G-code in RepG, and you could just put 0 in there. Then up here, if I'm using both heads, you'll see a T1 and a T0 head. It's a little bit confusing, but T1 equates to the left hand extruder, and then the S next to it equates to the temperature. So this is defaulted, because I haven't obviously recompiled it, 220 degrees, but you can just change that to whatever temperature you want. And then when you're ready, and there are other things down here that I haven't spent a lot of time looking at, but you can see essentially there's a lot of code here that's telling the head where to move to and what to do. And then when you're ready, you click this button, which will create an S3G file, or if you're connected, you can actually start printing. I'm not too keen on having a computer switched on for a very long period of time, and even a modest print can easily take 10 to 20 hours to print, unless it's very small indeed or very low resolution. So I'm going to come out of this piece of software now and go into MakerWare, which is another piece of software which is free to download. So I haven't got anything loaded into here now. Basically works on the same principles. Need to make sure you've got the right bot, as they call it, selected. So my printer is a version, if you like, of the Replicator Dual. So I can now load in my file, which is this one that's coming in now. Now, because the object isn't completely on the build plate, it's giving me a warning, and I'll say move to platform, and you can see it just moved it up slightly. You can see that already the dimensions must be right. We can check them, but they must be about right, because it's about what I expected it to be based on the size of my build plate down here. I have found some slight differences in where the origin for the build plate is for the MakerWare compared to RepG. Possibly RepG is slightly more accurate. MakerWare seems to be out for my printer by about 5mm. It sort of comes off the end here. We can move the object around as you'd expect, very much like the previous one. We can center it, and we can scale it. So we can see at the moment it's just over 101mm in height, or 10 centimeters, which is what we wanted. Under here we can select the material. So currently it's using the right extruder. I've got two different colours in Makerware to indicate the left or right extruder, and of course you can dual extrude, but we'll do that in another tutorial. So I'm going to go with the right extruder, and I've got some white PLA in that. So once you've selected what extruders to use and got the object where you want it, you can now go to Make. Before I do that, actually, there's something I should say about having both Makerware and RepG on your computer at the same time. Apparently there is some interaction between a service that Makerware installs and RepG. So if you're going to use the Replicator G software, you need to run Makerware and say stop background service. It'll say that, and then you'll see background service unavailable down here. So this will not make the slicer file while that service is unavailable, but obviously you can use the RepG software. When you do want to use it, you can just go and restart the background service or reboot the PC and it'll start back up again. And there you go, it's available. So we can now click Make. There's things which are better about Makerware. It's certainly a lot faster, but there's some downsides as well. You don't have quite the same level of control. And I find profiles rather hard to manage as well, so I tend to ignore them. But ignoring profiles means you need to remember what to check every single time you create an object. So I'm going to say low resolution, just as a starting profile. Infill, I'm going to say 100% because essentially we've got a very thin object anyway. I'm going to say one shell, so it'll probably just run around each side once because I don't think there's enough room really for much more than one shell. You can't go to 0 the way you would in RepG. And I'm going to say 0.2 millimeters for the layer height. And now for the temperature. The left extruder is the one that I don't want to use, so I'm going to set that to 0. The right extruder, that's a little high for PLA. I'm going to go for 205 degrees. Some may be shouting now that that's too high. I found it to work quite well with the material I'm using, at least when I'm not doing a lot of overhangs. And I don't need the heated build plate on because of this shape. Speed, I find that a bit high, so I'm going to go down to 60 and 90. So this is how fast it moves when jumping from one place to another without extruding. This is how fast it moves while it's extruding. So that's still fairly quick. And now we come up to here. Do we want a raft? Do we want supports? I don't see any real need for supports. Yes, there's some slight overhangs from here, but frankly they're very minor, so hopefully it will work. So we'll say off for supports. I'm going to turn raft off as well because this has got a good contact with the base, and I find I get pretty good adhesion using masking tape or builder's tape or painter's tape as it's sometimes called. So I'm going to set that to off. The fact that it's got MakerBot ABS in there, I could have changed it to PLA. This is just the starting point. Once you've selected this, you don't need to change anything else. So once you're happy with that, you can then click export. If you want to, you can preview and it will offer you the option to see where the head is moving as well. So I'm just going to click export now, and it's going to choose a file, and I'll come back when that's finished. Okay, we can now see that that's created a .x3g file, which is the format my printer needs. You need to make sure you print to the right standard for your printer, and I'm just going to take that now and copy it to my SD file. So here's the SD card that I've put the x3g file on, which is the format this printer needs. Put that in the side, and the first thing I'm going to do, as you can see from the menu, I'm going to level the build plate. With this piece of paper, this is really just to set the height of the hot end or extruder to about 0.1 of a millimeter above the surface. And you get some instructions on the menu, and then the printer moves to several locations. Exactly how it works depends on the version of software you've got in the printer. I've got the factory build software at the moment. If you have some later versions like Sailfish, you move the head around yourself. So you just feel the paper. If it's grabbed a bit too tight, you adjust these knobs underneath the build plate to loosen it off or tighten them up. You actually tighten the knobs in order to pull the build plate down and loosen the paper, or loosen them to do the reverse, because obviously you're adjusting from underneath. And then it moves to different locations each time you OK that setting. It goes to 4 positions around the outside. See, it's doing the other side now, and I move the paper to keep up with it. Sorry, the camera's jiggling around a lot. I'm obviously trying to do 2 things at once. And then it goes into the middle to just check that, which is the most important place to get right, obviously. Leveling the build plate is quite important. If you don't have it level, you will struggle to get good prints, whether because they don't stick to the build plate properly or they don't extrude properly. So once that's done, we can either quit the process or just finish it, and we can come out of the utilities and go into the SD card, select our compiled code. So this is the 3D printed one, and off it goes. First thing it does is it homes the print head, and you can see the build plate moved up there. Now it's dropping the build plate down while the print head heats up. And if it was heated, the build plate would heat to temperature as well. My printer came with blue lights, as you can see. I'd have rather preferred it was white lights, and I often use a torch to be able to see what I'm doing. You can see there's a lot of masking tape or printer's tape, and that's what I'm going to print on. And you can see the right extruder is coming up to temperature now. The left extruder and the platform are just at whatever temperature they're at. When it gets to within about 5 degrees of the set temperature, the print will start. In general, you want to print toward the lower end of the ideal print temperature so that the extruded plastic cools as quickly as possible. So you can see there's its plastic starting to come out. Because I compiled this in MakerWare, you can see it thinks it's on the plate and it was actually off the end. It's not a real problem at the moment. And there it's drawing the first circle, or attempting to. And you can see there's a problem here because the build plate isn't completely leveled. The height, to be more precise, isn't quite right. So you can see it's just not sticking. So trying again, it's just coming back up to temperature. I've adjusted the build plate again. I think it's fairly level, but the height was probably not quite right. Once you've got the build plate level, it will usually hold its level for a while, but at the moment, depending on your printer, my printer has plastic arms for the build plate, and so they vary a bit with temperature. So here it goes, having another go. Be careful if you do what I just did, because obviously that print head's over 200 degrees centigrade. So you can see here, it's drawn a circle and it's now filling it in. So this is the first layer. So that's essentially the shell. So you can see it's at 2% at the moment. So here's the result, and you can see that the texture I put on it is visible. It's flaring a bit in the camera, but you can just about see it's a pretty nice print. I'm quite pleased with the result. It's a very subtle texture, but I'll highlight it by painting it slightly in a little while. So there it is, slightly better focused. You can see there's little sort of strings inside from where it's just printed. And it's a nice smooth base as well. There's a little bit of tape left on there. It's slightly tricky to get off. So I'm now going to paint this just with some acrylic paints, and we'll see what it looks like afterward. And here it is. May not be to everyone's taste, but I quite liked it. I put a gold rim on it and highlighted. I painted it black first on the outside, and then used a technique called the dry brush technique, where you just use very little paint on the brush and just paint over the surface. And this sort of highlights, basically hits the high areas with the paint that you're using. And I decided to leave the inside clean, and it's quite a nice effect. Certainly quite interesting. And measuring it, your camera wouldn't focus well enough, but it's about 59.2 millimeters on the inside diameter. Remember, I set it to about 60 millimeters or 6 centimeters. And on the outside diameter, it's about 63.2 millimeters. And it's about 2.4 millimeters thickness for the wall. Here we are back in Blender, and we can see that the overall size of the internal diameter is pretty close to what we ended up with. I have found the amount of shrinkage does vary quite a bit. I think thin-walled objects like this don't tend to shrink as much as solid objects, so it's worth bearing that in mind, but generally they do shrink. And there are some other effects to do with the way that a 3D model is converted into the real world, because obviously a 3D model has finite sections, and that's part of the reason that I like to use fairly high number of vertices. We can see this model is constructed of little pieces here, and when it prints it, it will tend to smooth out these areas. So what you'll tend to get is it will effectively shrink this internal diameter slightly. That's only really an issue with either very size critical parts or parts that have quite small apertures in them. So overall, I think the print came out quite well. I'm very satisfied with it, and I hope you found some useful tips along the way. I'm still learning on how to use my printer, and I'll certainly be posting some more videos about 3D printing, whether it's home 3D printing or using companies like Shapeways to print things for you. And if you want to learn more about Blender, you can find out a lot more about it on my other channel, Sardi Pax. So I hope to see you in the next tutorial or discussion. This is going to be a sort of mixed channel, so it won't always be about 3D printing or always about Blender. It'll be whatever I think might be of interest. See you in the next video.